This is the last topic of this tutorial, and we're going to talk about physical models of hearing. So physical models, they don't model the effects of hearing, but the physical functioning of the inner ear instead. As a result, their output is an internal representation and not a masking threshold as we've been seeing before. Those models can still be used to compute a similarity measure of two different sounds as perceived by the human ear by comparing their internal representations. One example is the PMOQ measure to estimate the quality of a sound compared to an original. And here you can find this paper at the IEEE, the PMOQ, a new method for objective audio quality assessment using a model of auditory perception. And it's a very interesting read. And as a student of the Technical University of Uminal, the Uminal University of Technology, you have access to these papers, and you have access to this IEEE library. So if you don't know how to download them, you can ask the library or the IT department. Those models is also used as part of the PEASS toolkit, the perceptual evaluation methods for audio source separation. And this is a toolkit that provides software, a database, listening tests, a GUI for MATLAB, and a set of examples. And you can take a look at the website and also the subjective and objective quality assessment of audio source separation, which describes also the toolkit and also the PMOQ models. And those models is used, for instance, for measuring the quality of audio source separation. So as I mentioned before, there is no masking threshold, and we're modeling the physical hearing, the functionalities of the inner ear. And so we have here some filtering simulating the basilar membrane. Then we have some low pass filtering. We have half wave rectification, some part for adaptation, some part for modulation, filtering, and you can learn more about this by reading these papers here and here. So that's it. This is the end of this tutorial, and I'll see you next time.